This is an application of MVT, mean value theorem. We are given that marathoner ran 26 miles city marathon in 2 hours and 15 minutes. Like all other runners, he started from a stationary position. Let us assume S of t represent the position function. It says stationary position. What does this mean? This means at 0 hours, he covered a distance of 0 miles. So we write this information, we write this stationary position as S of 0 equals 0. At 0 hours, he covered a distance of 0 miles. After a time of 2 hours and 15 minutes, he completed his marathon and covered 26 miles. First, let us convert this 2 hours and 15 minutes into hours. For that, we divide 15 by 60. We convert these minutes into hours by dividing 15 by 60. That means we have an interval of 0 to 2.25. We need to apply the MVT on this interval. So, after the time of 2.25 hours, he covered a distance of 26 miles. Since position function is a continuous and differentiable function, so we can apply the MVT over this interval. Using MVT says the derivative s prime t equals to the average value of the function. This gives us a velocity of 11.56 mph. Since s prime t represent the velocity, the derivative of position function is velocity. This shows the runner was running at this speed at least 1 point during his run. Let us understand this with the help of a graph, velocity graph. Interval is from 0 to 2.25 hours. Velocity, he started with a velocity of 0 from the initial point and touched a peak of 11.56 mph. He reached the peak of 11.56 mph velocity, and when he reached at the finishing line, his velocity was 0, again 0. While reaching to its peak, it must have crossed the line of 11 mph. It started with the velocity of 0, reached to a velocity of 11.56 mph, and while going from 0 to its peak, he crossed the 11 mph velocity first, and secondly he crossed the 11 mph velocity while coming back from peak to 0 velocity at this point. So this means he must have touched the 11 mph velocity at least twice. Runner was running at exactly 11 mph twice.